BMW and Toyota join forces again, this time for hydrogen. And Germany goes all in on hydrogen rail lines. All of this on today's Hydrogen Podcast.
So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
In an article from the DetroitBureau.com, Paul Eisenstein writes, BMW readying hydrogen SUV and Porsche may follow. BMW is getting ready to launch its first hydrogen-powered vehicle, a version of the X5 SUV, and it expects to bring it to market by 2025, this according to a senior official. The government automaker's fuel cell vehicle is being developed as part of a joint venture with Toyota, itself one of the industry's biggest advocates for hydrogen technology. It currently sells the Mirai, and BMW's new iX5 Hydrogen would use similar technology. But BMW isn't the only German automaker getting serious about hydrogen power. Porsche is exploring the use of the lightweight gas as an alternative to gasoline to fuel an internal combustion engine, rather than feed a fuel cell stack. Ironically, that's an approach BMW explored for a number of years, but has since abandoned. According to BMW sales chief Peter Noda, we see that the hydrogen fuel cell technology is particularly relevant for larger SUVs. He also says that it has various projects in the works with Toyota, hinting that more fuel cell vehicles could be coming besides the iX5 Hydrogen. Now, the two automakers have a similar philosophy that, while both are aiming for zero emissions, calls for the use of a variety of different powertrain technologies. These include not only pure battery electric vehicles, but hybrids, plug-ins, and fuel cell vehicles. The latter technology pushes pure hydrogen gas into a device known as a fuel cell stack. There it combines with oxygen from the air in the presence of a catalyst such as platinum. Electrons are stripped from the gas and are used to power electric motors rather than batteries. That's why the technology is sometimes referred to as a refillable battery. And there are some key advantages. One being that a fuel cell vehicle, or FCV, can store significant amounts of hydrogen on board. In the Toyota Mirai XLE, that provides up to a 402-mile range, this according to the EPA. And those tanks can be refueled as quickly as a conventional gas tank. There are also a number of downsides. Producing pure hydrogen is energy intensive, and the cost is relatively high. Plus, the distribution network is even smaller than the rapidly growing public charging network. But the demand for fuel cell vehicles is growing. This according to Jack Hollis, the new head of North America sales for Toyota. And in turn, U.S. demand for the Mirai has been growing. Germany and several other European countries, meanwhile, are setting up their own hydrogen refueling network alongside EV charging stations. Again, according to Hollis, no one sees fuel cell vehicles as a better solution to battery electric vehicles. They're both needed, and they both have a place. Patent renderings of the BMW iX5 Hydrogen reveal that SUV will mount a number of hydrogen tanks below the vehicle's load floor, much the way modern EVs place batteries within a skateboard-like platform. The application will mount the tanks on floating bearings that would allow them to shift position in the event of a severe side impact crash to reduce the chance of rupturing. But what about Porsche plans? While BMW is rapidly moving forward towards bringing the iX5 Hydrogen to market, Porsche appears to be in the much earlier stage of development with its own hydrogen technology. Its approach is to feed the gas into a 4.4-liter twin-turbo V8 where it would serve as a replacement for gasoline. The automaker said the approach would match the power of conventional engine package at about 590 horsepower, but it would have virtually none of the emissions. Hydrogen produces nothing but water vapor when used in a fuel cell stack. Burned in an internal combustion engine, there is a relatively insignificant amount of oxides of nitrogen produced. And for the moment, Porsche said it has no production plans for the hydrogen V8, but it is exploring other options. Okay, so good news for the fuel cell EV market. And it's really no surprise that Toyota and BMW are pairing up on this, as they have had great success in the past when partnering up with vehicle designs such as the latest Toyota Supra. But what's really interesting about this article is the inclusion that Porsche has plans for utilizing hydrogen also. And why is that important? Well, if you don't know, Porsche is owned by Volkswagen. And Volkswagen's CEO Herbert Diess has been openly hostile about hydrogen and e-fuels as alternatives to electrification on social media. So the fact that Porsche is publicly stating that they're looking into hydrogen internal combustion engines speaks volumes for what's going on within Volkswagen. Next, in an article from DW.com, Mark Hollum writes, German train line switching fully to hydrogen. A local train out in Germany is becoming the first to run a fleet of hydrogen-powered trains. Hydrogen could be a zero-emission rail solution on quieter lines where electrification is too expensive. A local train line not far from Hamburg will start operating exclusively with hydrogen-powered trains using a fleet of 14 produced by French company Alstom. Lower Saxony's state premier, Stefan Weil, attended a ceremony in the town of Bremerförde on Wednesday to inaugurate the all-hydrogen line. The first commercial test of the new type of train took place on the line between Cuxhaven, Bremerförde, and Buxtehude back in 2018. But some hydrogen locomotives have been running on the roughly 100-kilometer line ever since. But that was alongside the diesel-powered trains that still did the majority of the mileage. According to the local rail network in Lower Saxony, the project aims to save around 8 tons of CO2 emissions annually. The €93 million project involved designing the Coradia Island trains in the southern French town of Tarbes and assembling them in Salzgitter in central Germany. The German DLR Space Agency's Institute for Concept Vehicles also contributed to the research. Developers hope that hydrogen trains could provide a zero-emission solution for rail travel on lines that are still using diesel, which powers around 1/5 of train journeys in Germany. The Alstom trains have also been used elsewhere in Europe, including in the Czech Republic, and hydrogen-based public transport solutions are being showcased more and more. 2 short-distance hydrogen trains were on show in Glasgow in the UK last year for the COP21 Climate Summit. Russia and China are among the countries to have started experimenting with hydrogen-powered trams or streetcars. Other companies are also looking into the technology. German engineering giant Siemens tested its first prototype hydrogen train this year, hoping to roll it out in 2024. Okay, so why not just electrify the line? Most major rail lines in Europe and Germany are being converted to run using electricity. However, unless used local lines, the high cost of electrification cannot always be justified. These costs can become particularly prohibitive if obstacles like tunnels and bridges require alterations to allow for clearance. Electrifying train tracks requires either a third line, which is uncommon on more rural routes, or overhead cables. Roughly half of Europe's regional trains still run on diesel. The Coradia Island trains fuel up with pure hydrogen, gather oxygen from ambient air, and a fuel cell converts the 2 inputs into electrical current. The only waste products at the point of power generation are water vapor and heat, meaning developers tout it as zero emissions. In some ways, the system is more like an internal combustion engine than a battery-powered vehicle or a train connected to the main electricity grid. It continuously uses hydrogen and air to create the electricity and requires refilling with hydrogen when empty, whereas batteries tend to use a chemical energy stored within them. Famously, Toyota, the first company to have a big commercial hit with partly electric mobility with its hybrid Prius, has since switched the majority of its e-mobility research to hydrogen-powered cars. One of the perceived benefits is the ability to refill the vehicle with hydrogen at a pump, not unlike the current system with petroleum, rather than to have to charge up the batteries. Partner company Linde, a world leader in making hydrogen refueling stations for road cars, is opening a first hydrogen refueling point for the trains. According to the developers, the trains have a range of up to 1,000 kilometers between refills and can be refueled in 15 minutes. German Chancellor Olaf Scholz and his deputy Robert Habeck, who is also Minister for Economy and Climate Protection, have just returned from a trip to Canada, whose main purpose was inking a new agreement on future green hydrogen imports. Okay, so a big step forward for hydrogen rail lines in Germany. And it's a good thing that Germany and Canada were able to reach an agreement for Canada to deliver hydrogen to Germany, as it's looking like Germany will have the highest need for hydrogen globally. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcast, Spotify, Google, whatever it is. That would be a tremendous help to the show. And as always, if you have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. And as always, take care, stay safe. I'll talk to you later.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.